As you can see, we have the board pretty much soldered up, more or less. We have all the components soldered in and a bunch of wires dangling off of it. They're going to go to the tube sockets, potentiometers, input jack, all that stuff. You can see there's jumpers on the back connecting some of that together. We also got started on wiring in some of our sockets. I started with the rectifier socket. The yellow wires are the filament voltage for the rectifier, which are 5 volts. The red wires are the high voltage coming from the transformer, high voltage AC, that gets turned into high voltage DC coming out of the rectifier. And the green ones are the filaments for the rest of the tubes. Those are 6.3 volts roughly. The reason we twist all these wires right here is that's all AC voltage, and if you twist it, it helps cancel out any AC noise that might get into the amp itself. So my next step is going to be to put that board in the chassis and carry on with the wiring.
I thought I'd go over with you what I changed in the stock 5E3 style circuit and kind of make it my own. The Tweed Deluxe style is a great amp. They're easy to build, and they're also great for modding and trying different things. They're a great starter amp if you're getting into amp building. After messing with them for a while, what I kind of settled on is mostly in the power section. That's where I make my changes. To start with, I'll replace the 5Y3 rectifier with a 5U4. That does two things. It actually ups the voltage in the amp, but gives you a little more clean headroom. And two, there's less resistance in the 5U4 as compared to the 5Y3, which takes away some of the sag that's in the amp. Kind of tightens up the lower end a little bit. Another thing I do to do that, tighten up the lower end a little bit, is put a 47 microfarad cap in my first stage of filtering, and I'll put 22 microfarad caps in the next two stages. That'll also help tighten up the lower end and not have so much sag in the amp. On the older, lower wattage amps, Fender never used to put screen grid resistors in. I'll add 330 ohm screen grid resistors into the amp. It does two things: lowers the screen voltage to below the plate voltage, and also limits the screen current. So this it changes the amp feel a little bit, but it also helps extend your tube life, especially when you run higher voltages and run the bias hot like I do. The next thing I'll do, or actually the last thing, the front end stays pretty much all the same. And the last thing I'll do is roll off a little bit more low end by changing these 0.1 microfarads going into the phase inverter to 0.47. So basically most of my modifications revolve around adding some voltage to clean it up a little bit and tightening up the bottom end and rolling off some of the bass in the power section. As far as the actual wiring and layout of the amp, there's not a lot to change. You can pretty much follow this and build a good sounding amp. Of course, nowadays there's no need for the ground switch or the death cap as they call it here. You can leave all that out and use the 3-prong grounded power cord. One thing I will mention with these amps, this 0.02 capacitor right here, if you look, it's actually tied to the grid on one side of this 12X7. If you come over, it's tied to the plate here. With grid wires, you definitely don't want to have them any longer than you need to. You can pick up interference and stuff like that. So you really don't need to run this cap right here. I'll actually get rid of basically all this wiring right here and take this cap and go straight from here to the grid, straight across. So that gets rid of all this excess wiring and any interference issues you could have. That's a good little trick when you're building this style of amp.
Alright, we got everything wired in and we're ready to start it up for the first time. I'll go over my startup procedure that I do with any new amp I build. First things first, you always want to make sure you plug it into your current limiter. That way if anything's shorted, it'll keep stuff from blowing up or frying on you. The next step is I'll always start stuff up without any tubes in at all. Make sure there's no shorts anywhere, and that way it won't blow up any tubes. So start it up, no tubes, check for shorts. I'll add the rectifier tube if it has one, check for shorts, power tubes, preamp tubes. And once you've done all that, then I'll still leave it on the current limiter. And if it's got adjustable bias, I'll kind of adjust that a little bit to make sure I'm not red plating the tubes or any power tubes. And then I'll maybe play through it a little bit, make sure stuff is working, all the knobs are working, don't get any weird noises coming from it. One thing to remember when going through the current limiter is that it's draws your voltage down on your amp. So you won't see full voltage while you're plugged into the current limiter. With tube amps, it's usually not too big of a deal. If you're using an amp that has like low voltage switching or something like that, or solid state amps, you can kind of screw with stuff, being is taking that low voltage and dropping it lower than it takes to turn the transistors or relays off and on. So let's fire it up and see what happens. Just a quick reminder, when working on any electronics, make sure they're unplugged, and especially with tube amps, make sure there's no voltage left in the amp. The filter caps can hold the voltage for quite a while sometimes, so always check with the meter to make sure there's no voltage left in the amp before you start working on it. The voltage in there could kill you. They are quite high and quite dangerous. Alright, before we get too far, we should probably talk about biasing. The Deluxe is a cathode biased amp, so we're using this resistor here to adjust the bias current in the power tubes. Cathode biased amps are a little more forgiving. They're almost a self-biasing amp. Once you get adjusted, you can swap tubes out and stuff without usually too much of a problem. You definitely want to check that when you're firing it up, especially when you're not on the current limiter, that you're not red plating your tubes, which they would actually turn very red, and you could destroy your tubes that way. I've built enough of these to know that 470 ohms is going to get me right in the ballpark where I need, so I'm not too worried about it being biased too hot. So I'll show you how to do that. We'll check voltages and calculate out the bias of this amp.
When you're talking about biasing tube amps, you need to know the max plate dissipation of the power tubes you're using. What I have pulled up here is the data sheet for the 6V6GT tubes I use. And if you look, that'll show you the max plate dissipation is 12 watts for these tubes. With a cathode bias amp, you can bias them pretty hot and bias them closer to that 12 watts than you could if it was a fixed bias amp. Fixed bias amps, you would only run probably about 70% of that. And the reason for that is the cathode bias amps controls the plate current more, so when you're playing really loud, I won't red plate the tubes or go over that max plate dissipation. And for calculating my bias, you can do it with a calculator. It's pretty easy to do, but Weber Speaker's bias calculator page is pretty awesome. It allows you to calculate stuff out real quick, and it's really handy. So let's put in our figures and see where we're at. How many tubes share the same cathode resistor? 2. The voltage across your cathode resistor. On this amp, it's 29 volts. The value of my cathode resistor is 470 ohms. And my plate voltage, now this is plate voltage measured between the plate and cathode, not plate to ground, because the plate to ground voltage is actually higher. So you're taking into account with this the actual cathode voltage off of that. So my plate to cathode voltage is 392. You come over here and hit calculate, you'll see I'm running 11 watts plate dissipation on the tubes at 29 milliamps of current for the tubes. Now that's pretty hot. Like I said, if it was a fixed bias amp, you wouldn't do that. You would probably run it closer to 21 milliamps, which is about 70%.
Alright, we got it in the current limiter. We're gonna fire stuff up here, and you probably won't see anything with the light right now because I have no rectifier tube in. So definitely no dead shorts there. Stick the rectifier tube in. And we'll let it warm up for a little bit. And we can flip the power and see what happens. As you see, just kind of a little dim and off again. So no shorts there. Put the power tubes in. Let them warm up a little bit. Now we just get a light glow, no bright glow, and that's normal. So no shorts there. And then we can move on to the preamp tubes. We'll let those warm up. And again, no bright light, just a dim light, which is fine. So we have no shorts in the amp, so we're ready to go on to the next step. Alright, next step is I'll actually run some signal through it, through my signal generator. I know it's a lot more fun to use a guitar to do it, but sometimes it's just handy to turn that on and make sure we're getting sound out of where we need to get it. So, I don't know if you can hear it or not, I got my load box turned down. I'll turn it up a little bit there. And yes, this can get annoying, but I'll check features like volume. On that input works, make sure the second one works. With the Deluxe, the tone control interactive, if I turn the second one up, it'll actually cut off the signal for the first one, and that's normal. Tone. Let's, so the tone is working. Let's go to the next input. So there we go. We're passing signal and everything seems to be working good. Alright, after we have the amp fired up and checked everything, make sure it's not biased too hot and there's no shorts in it or anything, and run some signal through it, I'll take a voltage chart and write down the tubes and all the voltages in the place and cathodes, things like that. And it's kind of a nice reference to have. I'll compare it to other amps I built, see how close it is. Sometimes you can see if there's something wrong or not right, or you got a wrong component or a bad component in there if you check your voltages. Of course, one of the best parts about building amps is actually getting to play through them. I can't quite finish this one up yet. I'm still waiting for the cabinet to arrive. Once that does, we'll get it put together so you can see the finished product. And then hopefully get some sound samples of it to give you an idea of what it sounds like. If you've enjoyed these videos, please hit the like button, hit the subscribe button to see future ones coming up, and hit the notification button also if you want to be notified when I post a new video. Until then, enjoy.